Firstly, thank you everybody for making it this far down the building this late in the event. I found out just before that there's in fact another presentation right after ours, so I'm impressed that we're all still here. So my name is Bruce Harold. I'm a product manager in the desktop team. I'm product manager for geocoding. With me today is Victor Bhattacharya. He's a developer on the geocoding team, and today we hope to give you some insights on how to improve your high-performance batch geocoding. So I've always sort of addressed data as location data that's spatially challenged. I mean, you might colloquially know where it is because you're in tune with your own culture. You can read an address. It becomes very instinctive after a while. But for a computer, it's a whole more different problem. There are search engine approaches. There are lots of different approaches. But what we've done at Esri is tried to learn the world's addressing cultures for you, and we set for ourselves a set of goals. I'll just go through them here. We don't want you to have to overthink the problem. Like, is there a spelling mistake? Don't stress about that. Is my data somewhat variable in the fields it's arriving in? Is my data just in one field? We tried to catch all those little wrinkles for you and let you process your data the way that you get it. Now, false positives are addresses which are matched badly. So if you got, say, the house number wrong and it matched to the wrong house number, that'd be a fairly gross and fairly obvious error. But if there was enough of a spelling mistake in part of an address and it found its way into the wrong location, then it's polluted your geodatabase, and it's an expensive problem to have. So at the cost of lower match rates, Esri's approach will be to constrain the number of false positives to a minimum. Now contrast that with a search engine approach, which is always trying to find you some answer. So we have not gone down that route for 99% of the world's geographies because we can do better with the way we have done it. So you can look forward to, well, there may be, say, a slightly lower match than some other competing technology, and we would like to think that we have fewer false positives. Now, auditing results is well supported. So you can look with the meta fields that come out after geocoding for the quality of each individual match. The address type is given to you, like how it was found. A percentage score is given to you, so you can see the quality of the agreement between what went in and what was in our index. And there's other things like, say, rank. Did you have to look further down the fields in the reference data for finding a match for the data? Remediation is well supported. There's things like the rematch dialog, where you can go in there and interactively look at the way the addresses were found and correct them. So you can teach the system where to put things on the fly. So if you find a pattern, you can edit the data in bulk and rematch just those records, and they'll improve their spatial location. The same API is available across our development environments, and the same geocoding engine is implemented in desktop, enterprise, and online. So what you'll see today is available to you commonly across the platform. We have global coverage. There's 130-ish countries. It changes pretty regularly, which are all covered, and you'll be able to geocode globally. It's scalable. That's what we hope to show you today. So you can both do things on your desktop at the pace at which your local computer can manage, or you can scale it through enterprise and through some other approaches. And like I said before, a common API. So what's new in geocoding? So Victor and I have done this talk a few times, and basically the dev team have done such a good job with our latest releases that the performance of batch geocoding has natively improved. And a lot of people are very coy about how fast their geocoding goes, and we've said to people, if they're maybe in the quiet conversation, well, you can expect 1 million per hour per core on your server. I get, on my laptop, which admittedly is a fairly high-end one, I get 1.6 million per hour, no trouble at all, for US-wide data. So it's a 6 gigabyte locator, so 1 million addresses, it'll be done in 45 minutes. So that's like a 60% improvement over the older technology. I'll get to the additions of technology in a minute, but that's an immediate improvement that natively makes it faster. We're still going to show you some acceleration approaches because they're there and they may be worth doing for you, but by the middle of this year, when we ship our next release of ArcGIS Pro, you'll be able to make your own locators with this natively faster and better technology. If you use geocoding in ArcGIS Online with the World Service, that's where you will see the new nascent technology in action. So as well as higher performance, it has better quality. It's got noise rejection, more address matching types like near intersections and going beyond a known range for a street and things like that. So if you want to play with it now, all you have to do is use ArcGIS Online. There's an early adopter program for the new Locator technology. It's wrapped up within the StreetMap Premium product. If you check with your account manager, you can obtain access to the early editions of that technology now. So in Pro 2.1 and Enterprise 10.6, you can try out the new geocoding technology for yourselves while we're rolling it out. Some other notable features: now there's only one locator in the new technology. There's no concept of a composite. So no more filtering through a stack of locators you have to put together. The new locators put all geometries into one locator in one file. There's no more locator tuning. You don't have to stress about whether or not you're having to allow a certain amount of memory per locator in a composite. You don't have to sort your data. The current engine is essentially a spatial index. So when it looks for a geocode, it's going to look through, say, the state of California, then the city of Palm Springs, and then it's going to start looking for street names. The new engine doesn't work that way, so we don't have to worry about sorting our input data to make use of some kind of chunk of the index that was previously brought into memory. What's noise rejection? Say if we have honorifics like somebody's name or a building name or some piece of junk, parenthetic remark, that came in the address. If that piece of the input doesn't explain the address and all the way down the chain to the XY, it gets chucked out and it gets put into its own output field. So you can think of the geocoding as the complete answer to not just find an XY coordinate, but the scrubbing, the cleansing, and the standardization of your data all in the one hit. So more match types, I mentioned a couple. Near intersections of streets don't quite intersect like they're like this, or there's an overpass situation. We'll let them match if they're within a tolerance. And roundabouts, or what we say traffic circles, I think you call them in Florida, they've got a lot. That's another match type we support. So the two street names that you gave don't physically intersect, but they meet together at something that connects them. Then we'll find the midpoint along the items that connect them and give you that as the geocode. So what are category filters? Category filters are a way to specify the type of match that you will accept. If you will only accept a rooftop geocode, then you say the category you will want is point address only, and that's the only results that you will get. If you're okay with a, say, less precise match like an interpolated one, you can add that category filter in at runtime and get those two types back. And there are hundreds of categories in the category filter. It goes right down to points of interest like styles of restaurant, if you're hitting ArcGIS Online. So if you're looking for Greek food in Redlands, you just say, these are categories I'll accept, type in some name of something you might have heard with spelling mistakes, and the system should find it for you. So what are desktop suggestions? If you've used a geocode service since, I think, 10.5, you've had the ability to include in the index the type ahead, look ahead kind of experience in your web apps and in ArcGIS.com web maps. That now is available to you in the new technology purely in ArcGIS Pro. So you don't have to leverage a geocode service to get hold of suggestions. Okay, so what are best practices? I'll go through, I hate the word legacy when people talk about technology because it's kind of demeaning, because it's fantastic technology that you will have now. I'm going to spend a little bit of time going through the existing best practices for getting the best out of your geocoding in Batch. So, use ArcGIS Pro. You've probably heard that many times this week because we'd like you to migrate, but it's not for no reason. It's because there's more memory headroom with ArcGIS Pro. It's a 64-bit app. Existing locators need to page stuff into memory to make use of the things. If you've got more memory available to the application, then it's going to run better. So that's just comes with the architecture. So again, you sort your multi-line input data on zone fields, and it's a spatial index, remember, so the big spaces first, that's state, followed by city, then zip, and that will help the index be searched. If it's still in memory, then an adjacent record, spatially adjacent, will find the part of the index that it needs in memory. Solid state disk kind of speaks for itself. There's no seek time in a solid state disk, so you can find parts of the index faster. Set the data cache size to available RAM. I luckily have a 32 gigabyte of RAM on my machine. I can easily fit the entire US locator into memory. So I would allow in that parameter setting, let's go for 6 gigabytes of space in the locator, allowed for the locator. And lastly, set the thread count. In single locators, that's a setting you can right-click on the locator, and there's a slide coming up in a minute. Allow the thread count to be automatically set, and that will go to one less than the number of cores that the operating system can see. In a composite situation, you set the number of threads per member of the composite, and you would set as many, or if you needed to, you could set as many threads as one less than the core count for your machine. So that means if it's a busy part of the locator, like the point addresses, I might allow 2 threads there, 2 for the street segments for the interpolation there, and 1 thread for each of the other ones for the zone fields. That would be a typical approach. So that in a nutshell was a whole presentation, just that one slide of how we used to go about things and show people how to do them. And this is still the case now with the locators you're using today, but this is going to go away as you adopt ArcGIS Pro and Enterprise 10.6 during the year. So just a picture of how that looks when you tune the threads in a standalone locator on the left. There's a little pull down there for the performance options. Just set it to auto, then you don't have to think about it. And on the right, I've cut out some of the ugly code, I guess you'd call it, in the LOC file for a composite. You should be able to see that the number of threads is set to 2, 2, and 1 in those 3 members of the composite. And lastly, the use multi-threading parameter is set to true. So that's the picture of how you're doing things or should do things today. So let's immediately make a comparison of the existing technology and the technology that's coming along. I'll give a little demo of each. So here we are there. So I'm going to say, where we've got Kansas addresses sort. I'll go to geoprocessing and I'll geocode addresses open. So my input table here would be Kansas address sort, locator is loaded. I got one that's just Kansas, so theoretically this should go as fast as the existing technology can for that sort of state size problem. The input fields are recognized, and I'll output to Kansas result. So I think I loaded the locator earlier, and it shouldn't pause doing that. The layer on the map's gone away while it figures out that it's going to overwrite the layer, and there you go. It's making a liar of me that the thing's not loaded. That should work at 1,000,000 per hour. Let's stop that. I'll try one more time. That won't work, will it? Now the gods always get you in the middle of a demo when you've done this 1,500 times earlier in the day. It's not immediately cancelling. I will make advantage of this thing here. I'll end task. We'll go back to that immediately. Sorry about that. One more try. So, Kansas addresses that are sorted, the Kansas locator, the fields are recognized, Kansas result, and this time run. So just a core tool. Still, I would say it's not behaving itself. I do not know why. It is accelerating. I'll just let it run because it's going to complete in 50 seconds. A bit disappointing on the speed because it's all set up to make life easy for itself. Could have been something I did elsewhere. So to have the speed at whatever it is, it's going to be 1,000,000 or so an hour. which is what it is. So we'll let it finish. I'll go back to, I'll queue up something else. If I now definitely not my day, is it? Okay, one more time. I will end that task and move on from that demo to the next one. Okay. All right. So whatever speed that was going to finish at, which was roughly, on paper, 1 million an hour, that's okay. But looking over at the next demo I showed this little phase here, this is a Kansas locator on disk. It's whatever size it is. The LOX is 100 megabytes. So here's the US locator and the new technology, 6 gigabytes. So let's go back over to GP, and we'll say open here. Okay, so we will just play with the Kansas addresses, unsorted, so we're making it harder if it was in theory. USA locator, finds the fields there again. A little bit different experience to the existing technology. There's the ability to filter by country supported by the locator. We can put the whole world in a single locator, and we do for our own services. You might buy that from us too, but in this locator for the US, it's just the major states of the US and the territories and outer islands. So another change here, you can choose the output to be the drive-to coordinate or the rooftop coordinate for the property. So fingers crossed that I'm not going to get issues here. It doesn't start from 0, it'll start with a mouthful first. So things are looking good because it's using memory. So there you go. So I will let it complete because it should complete in about 50 seconds. Getting there. 1.3 million per hour, if you can read it down the bottom, near the bottom of the tool. At the end, it takes a little bit more time to read it. So 1.2 million per hour. So given that if it had completed, the Kansas one would have done the job at 1 million per hour, we got 20% improvement here in a much larger locator to search and with unsorted data. So there, that's a kind of a gimme for geocoding the new engine. Okay. So, can we do better? Many of our customers have many millions of records to geocode, and even repeatedly in their business workflows, if, say, people relocate, we have federal agencies that help large numbers of people who are relocating pretty often. They're geocoding millions of addresses on a weekly basis. So how do we help them do that with limited resources? I'll go through a few approaches. What's available? So if all I have is desktop, can I help myself in any way? Well, batch geocoding is what's called an embarrassingly parallel problem. It doesn't matter to the system or the result in which order any record in the table is geocoded. If some other business process of yours depends on the order of records, then you can re-establish an order based on some kind of sorting. But for geocoding itself, it doesn't matter. So I can split a job into a number of chunks and process them simultaneously, and all should be well. That's good. Now, luckily, modern computers have many CPU cores, so those would be the places to do this parallelized geocoding. That's good too. Now, we may have heard ArcGIS Pro makes a lot of use of threading. There's a user interface thread, there's geoprocessing threads. Really, Esri should design geocoding to make use of more threads for geocoding, and we have, and that's why there was that 20% improvement there. But you might want to really push it and make use of threads to your own design. This is where this work you'll see here and Victor's work in the office comes into play. Typically also you have access to ArcGIS Enterprise and ArcGIS Online. So those are places where there are geocode services available. So can we leverage those? The answer is yes, we can, and we'll show you how to do that. How do we bring these things together? Splitting one pro machine. Now historically I have shown, and I'll show again, an approach where all I have is a desktop machine. I know it's got 8 cores, it's got plenty of resources. Surely I can chunk a job up into pieces, run them simultaneously in processes and put them back together. You can, and I'll show you how going down that track works in Pro, but reading further down the slide here, the expense, the computational expense of splitting a table up into pieces and putting the results back together almost outweighs the benefits you get from running these sub-processes simultaneously. So there's a lot of overhead, and that is, almost defeats the purpose, except possibly for very large jobs, and the screenshot there shows for 1 million records. It might matter to you that you get 17% more per hour, but I think it's quite unlikely. So a demo of concurrent processes, just to put this thing to bed. What does that all mean? I'll get a couple of things open here. I'll go back to this directory here, which will come alive shortly. Open up my toolboxes. So if I was to do this, splitting the job into chunks, I can do it like this. I've got a script tool here, there's the code. I'm using this module here called subprocess. Really, it's just a fancy wrap of Windows command prompt, which you send stuff to, and it will go and do whatever you send. So with all the code here, it's just putting together a command that gets sent to the operating system, and it gets run. The command is run Python, run this script. The script that gets run is a really simple one. It's this guy here. It's a worker process. Okay, and barring the try except statements here, if I wanted to, I could get this job done in just the import statements and 3 more lines of code. It's just incredibly simple, because the heavy lifting is the actual geocode process. So let's get that guy going. And take it from there. I think the longest part of this is waiting for the tool to hydrate. I'll get through the next one. Okay, input table is New York. There's 4,000 or so addresses there. I'm going to use the new style locator. Process count, I'll leave it at 4, just for illustration purposes. There's a scratch directory where the temporary workspaces used are going to be created. That's all good. I can path to my worker process, and I'll overwrite, where is it? New York concurrent geocode, that guy there. So if I run the tool, the first thing that happens is 4 temporary workspaces are made. Those are file geodatabases made in my scratch directory. And then Python processes spin up. There they are there, coming live. They come and go based on how hard they're hitting. So that's the expense, the computational expense of spinning up Python, loading ArcObjects, doing the geocoding. There's no fast way to start these external processes. So off they go, and they will climb in the amount of CPU they consume until they're consuming it all. And then it's just a matter of waiting for the processes to complete. So there you go. I'm utilizing 100% of my computer's CPU resources, and it's working hard. It's famous. If I was paid by the amount of heat generated by my computer, I'd be very happy. But does it help us? So there's some code in there to count the speed of things. So it's finished now. I'm merging the results from 50 seconds, and I got 500,000 records per hour. I'd be better off for that case of a small job to have just run it with the core tool. Now, in the earlier slide, I ran 1 million. I got a little bit of gain, but not much. So I think my recommendation would be don't go down this path. We've done this now, tried it. It may be fun to code it, but it's just not necessary. And these scratch directories were cleaned up. Okay, so that was that demo. Oh, so that code, if you want it, is a geoprocessing sample in ArcGIS Online. Just look for concurrent as a keyword, and you can download it and have a look, see how it was done. There may be some other workflow that you want to use it for. So That was splitting one machine, not really worth it, right? But we can leverage geoprocessing services to offload the real work off to a server class environment. So that'll be the focus of what Victor and I show you for the rest of the show. So you can scale your geocoding bandwidth more or less linearly with the number of geocode services that you hit. And we're going to do this through the common API, or in both our cases, the REST API. And one more notable point, you would do this on-premise if your company or organization did not allow addresses to go to online there. So if you need to work securely, you can do all this in your own office. So concurrent futures. So I'll go to there, and we're going to look at some real estate transactions. As a look at the data, so dots on the map come from somewhere. This is some data I found somewhere on the internet. It's all a whole lot of real estate transactions in Sacramento, California. There's 1,000. Let's have a look at one of the ways of doing this concurrently. So I'll show you some code. The secret to this one is this module here, concurrent futures. It's a fancy wrap of threading inside Python. It's available in all installs, nothing you've got to do to go and get it. So all that's happening in this long list of code down here is that the data is read into batches of a variable size that you choose, and they all get sent, oops, not that, I did that, to the service endpoint concurrently. So let's do that and see how we do. So we've got 985 records to geocode. I'm going to make it a small batch size so you can see how things run concurrently. Now, I haven't made it smart enough to recognize fields. I should probably do that. Go to zip. But I have made it smart enough to support category filtering. So if my data had things like business names in there, I might allow point of interest matches so I could get to the Starbucks in Redlands or whatever it is I'm looking for. So if I was fussy, I don't want to have these guys here, I'll take them out, primary postal. There's no good matches. I'll allow those ones. Those are reasonably good quality XY coordinates I'm going to get. And the thing to watch here is, I'll just leave that one there. Save. So I'll run it, and you'll have to watch quickly, or pay attention is the proper, what I would say. First, my credit situation is checked, and see the batches are sent concurrently. They're going so fast that the whole thing gets done in a flash. So with a little bit of effort there, did it tell me the speed? I think it did further up. So that was 1 million per hour and didn't even get running. So if I had a really big file and I chose more threads, my Locator, my enterprise setup supported any number of threads, I can get millions and millions of records per hour, and we have users doing just that. So that's pretty much the end game for scripted geoprocessing tools in Pro. Do make use of enterprise geocode services, and you can scale linearly however you want. So all a client is doing is marshalling the data up to the server and back. So if I went to wherever that data landed, oh, that was right, no. Sacramento is where it was. There it is, that's the stuff I just geocoded, landed there. The gray's a bit hard to see, but those are the results. So that was a few approaches that are scripted. Again, you can go get this kind of source code from the samples that I've put up on the web. Get my card afterwards if you can't find these things. There's 2 of them. That was, you just saw hitting a street map instance. If you are a world geocoder for ArcGIS customer, that means you've bought the entire planet's worth of addresses. You can apply the same approach to your system to accelerate the geocoding for those. Okay, so that was my half hour, almost exactly. I'd like to hand over now to Victor, who's going to go through other portal-based approaches.
Thanks, Bruce. So, perfect. We're online. So, a quick outline of what I'll talk about So first I'll talk a little bit about the Geocode Addresses API, tips and tricks when using it and developing with it. And then I'll cover the Batch Geocode API, clients that use it, and how you would configure your on-premises portal and locator services to get the most out of the API. So first, I'll talk a little bit about the Geocode Addresses API. As a quick disclaimer, everything I'm going to talk about are REST methods. And depending on whatever language you're coding in, be it JavaScript or Python or whatever, as long as you're interacting with REST protocol, you can take all of these concepts that I'm giving you and do them in any language. But I'll be using Python. So without further ado, let's dive into the Geocode Addresses API. So this is service-based batch geocoding. Whenever you publish a locator service to your ArcGIS server, if you enable that service for batch, you get this endpoint for free. So you can go to this Geocode Addresses REST endpoint and perform batch geocoding. This requires a token if the service is secured. And if the service you're hitting is the ArcGIS Online batch geocoding service, then that token is also how we know who to bill for the addresses we give back to you, or the points, I guess. A little bit more in depth about the Geocode Addresses API. Each REST request geocodes from 150 to 1,000 records at a time. And it demands an input and output of JSON. So you input JSON addresses, and you get output of the points XYs. And this requires credits when geocoding against the online service. But obviously, if you stood up your own locator services on your own server, then it's free. So if you're only able to geocode 1,000 records at a time, that's not necessarily how much data you have, right? Maybe you have 2,500 addresses. So a first good tip in using the Geocode Addresses API is chunking your data. So since the Geocode Addresses API only accepts 1,000 records at once, maybe you'd want to chunk your 2,500 addresses into the first 1,000, the second 1,000, and then the last 500. So basically, this is the idea of submitting smaller requests one at a time until the job is completely processed. A quick example of what this looks like in code. So I'm using Python. This first line initializes a queue of infinite size, just so I don't have to deal with queue restrictions. Then I'm going to loop through all of the addresses. This line right here says, if I'm on the 1,000th address or the 2,000th address or the 3,000th address, take that batch of 1,000 addresses, put it in the queue. And so this way I'm queuing up batches of 1,000 addresses. And then once I've queued up all the addresses in the queue, I'll loop through, go through the entire queue and take batches of 1,000 addresses off the queue and send them and call geocode addresses with that group of 1,000 addresses. That's about it for the general concept of chunking your data. The next helpful tip I have for you with the Geocode Addresses API is retry logic. So with any REST protocol, you might get a server failure, right? It's over the web, over the internet. Did your internet fail? Was there a client error, a server error? All sorts of timeouts, anything could occur. So it's the responsibility of the client to deal with this and retry your addresses if they've failed. So Geocode Addresses is a synchronous API, and requests could time out or have a bad response. So it's important to know your status codes. So these are the common status codes that you get back from a web service. Now this last one is the one where you would want to do some retry logic. So a server error could be a timeout, anything like that. If you have one of the other problems, then retrying your addresses won't necessarily solve the problem. If you submitted them in the wrong request, maybe malformed JSON, you're not going to be able to submit that same request and get a valid response because it was just malformed. So if you do get a server error or a timeout, this is when you would want to do some retry logic. And any developer that's written some code knows that this comes with exception handling, right? So I'm making a post request in this snippet of code. In Python, in the request module, there's a function you can call raise for status. And if the status is a 400 or a 500, then it will throw an HTTP error. And basically, I have here that if the status code is a 500, then you'll want to retry the request. Now, I didn't really get into details of what the retry request method would do here, but basically what we do internally is if a request times out, then what we do is we cut the request in half and send the first half of addresses and then send the second half of addresses. So then if the first half of addresses succeeds, then we're done with that half, and then we send the second half. If the first half of addresses still fails, then we repeat the process. We cut that batch in half, send the first half, and then send the second half. So that's generally how we do our retry logic, but you guys can obviously play around and see what gives you the best performance. So those were 2 helpful tips for working with the Geocode. I thought they were helpful for working with the Geocode Addresses API. And there's actually another API that actually wraps all of this together and does it for you, called the Batch Geocode API. And this is what the the geocoding team has been working with. So this is a portal endpoint for batch geocoding. So if you have an ArcGIS enterprise organization, you can use this API. So the Batch Geocode API is a portal endpoint for batch geocoding. It's portal in, portal out. So if your table is on the portal in the form of a GDB table, a CSV, or an Excel table, then you can use this API and it will upload an output feature service, or you could also choose an output CSV or XLS to your portal. So it will take the table from the portal, geocode it using your geocoding services that are on your portal, and output the result to your portal. And I'll explain how this fully utilizes the backend geocoding resources that you've stood up in your organization. So a quick visual of how this works. You have your table on the portal, and you have your geocoding services stood up, and you want to geocode this table that's on your portal with the geocoding server. So this Batch Geocode API communicates with both parties, downloads the table, and geocodes it as fast as it can against the geocode server. And finally, it uploads the results back to the portal. And so the Batch Geocode API, as I'll show you shortly, is really nice because it allows the administrator to be in control of how much we want to hammer your geocoding services. The advantages of the portal batch geocoding is the administrator gets to control how much performance you can squeeze out of your locators. So in that way, you're able to manage backend resources. You can do all of this batch geocoding behind your own organizational firewall. And it has those tips and tricks that I talked about earlier built in. So that chunking and the retry logic, all of that is done for you. So basically, if you have your table on the portal and want your output on the portal, this is a great alternative. Clients that use the Batch Geocode API. So we've written some clients that are available today that leverage this API, so you wouldn't have to write custom code with the API. So on the left is the geocode locations from table tool in the map viewer. So if you have an ArcGIS enterprise organization and you go to your map viewer, you can use this API in the find locations heading. There is this new tool, geocode locations from table, that will geocode your large input tables that are already on your portal and output them to your portal. And on the right is the geocode table tool available in Pro 2.1. And this will, even if it's a local table, the geocode table tool will upload that table to your portal, do all the geocoding, and then put the result back on your portal and populate the map for you. So a quick demo of what each of these look like. So the geocode table demo in Pro. So I've got this USA 4,000 addresses. And if you right-click, there's this new button, Geocode Table. And so it will step you through the process of what kind of locator you're using. But I'll just go straight to the tool. You choose your input locator, so we see that is the world locator. And the fields look like they're mapped correctly. We'll go ahead and say that all of my addresses are in the United States since there's 4,000 USA addresses. And we want to check that box that says add the output to the map after completion. And then we click run. And it's on its way. So this USA 4K is a table that's on disk. And what this geocode table is doing is that it's uploading the table to the portal, performing all the batch geocoding, and outputting the results back to the portal. I want to leave some time for questions, so we'll do a little quick time warp here. And it says it succeeded, and it puts all the points on the map there for you. It says, would you like to rematch? And we'll say no, and that's what it looks like. The map viewer also leverages these new capabilities using the new Batch Geocode API. So a quick demo in the map viewer. So in ArcGIS Enterprise 10.6, we've got some content here. So I've got this table on my portal. This is 30,000 USA addresses in a CSV. So I head on over to the map viewer, click the analysis button, and under find locations, there's this new tool, geocode locations from table. Browse to the table I want to geocode, add it, and then we get our field mapping. And you can choose your output format here. So if you want your results in a CSV output, so basically the old CSV with the XY coordinates appended to it, you can also ask for a CSV output. But for the purposes of this demo, and since points on a map are nice to have, I'll click feature layer. The output name looks good, and we click run analysis. And this churns for a while. It's 30,000 addresses. I'll talk a little bit about what's actually going on. So when you have your locator on your server, what the Batch Geocode API allows you to do is it allows the administrator to specify how heavily you want to hit the geocoding service. So let's say your geocoding service has 4 instances running. Instead of sending one request at a time to a locator that has 4 possible instances running, you can configure the Batch Geocode API to send 4 requests at a time to fully utilize the capabilities of the geocoding service and get that job done as fast as possible. So behind the scenes, that's what these 2 demos have done. And after this demo, I'll talk a little bit about and show you guys another demo of where you configure the number, basically the parallelization factor of how much of the locator's resources you want to use. Do another quick time warp.
Hey, there it is.
And they're all the addresses. It takes a little while to draw since there are 30,000 on there. So let's talk a little bit about how you would configure your portal for optimal results for batch geocoding. So the first thing you'll want to do is obviously publish your locator to your portal and add them as a utility service. Once you add your locator as a utility service, you'll be able to see it in ArcGIS Pro as well as in the map viewer. Then you'll want to set the number of threads per geocoder via the sharing API. So if you see there at the bottom, there's this picture, there's this JSON, and this JSON contains all of the utility services in your portal. And what you do is you go into that JSON and you add this new property called num batch threads. And this is through the sharing API, so you have to be an administrator to be able to do this. And I know that this, for example, this StreetMap Premium USA geocoder has 8 instances. So I can scale up and say, I want the num batch threads to be 4. So basically, each job that gets submitted to the StreetMap Premium USA geocoder will have a concurrency factor of 4. And so it won't just submit one request to the geocoder, but it'll submit 4 concurrently and try to get the job done as fast as possible. You can scale up both your GP service as well as your geocoding service to get the most performance out of your locator. And what's nice about this is we found that the scale up is linear. So based on how big your locator service is and what machine it's housed on, depending on the number of cores you have, you can scale that up, add this num batch threads property, and get your geocoding job done 4 times faster or 8 times faster. It's really just dependent on the amount of resources you have available to allocate. And there's a configure portal to Geocode Addresses online help that talks you through all of this and how you would configure it. So I can go ahead and show a quick configuration demo of what this looks like. So this is the sharing API. You have to be an admin to be able to access this sharing API. So this is the portal self page. If you scroll all the way down to the very bottom, there's this update operation. So once we click this update operation, we can scroll down to the geocode service part. So the geocode service, you would want to go ahead and grab that JSON and edit it in whatever IDE you have of choice. I enjoy Notepad++, so that's there. And so there's a San Diego geocoder, and let's say I have the resources to be able to have that geocoder have 4 instances running. So I'll add this property, num batch threads. And set that to 4. And then we add this JSON back in. Scroll to the bottom. And update organization. And you can do this per geocoder. So let's say one of your geocoders has 4 instances, another one has 2 instances, so you can set the num batch threads property as 2 for the one that only has 2 instances running, and set it as 4 for the one that has 4 instances running. And this allows for a true linear speed up of batch geocoding in your enterprise organization. And that's about it for us. So without further ado, do you guys have any questions?
So when you add that parameter on there, you add 4 threads. It gives me a great experience, right? But if I consume everything on that batch service, what about the guy behind me? So I throw in 100,000 addresses. The guy behind me says, I'm going to throw it, but he's got nothing, right? He just sits in the queue.
Exactly. All right. So the question was, let's say I set my value to 4, but there's 2 users that want to do batch geocoding at the same time. So we leave that up to the administrator to figure out. So basically, if you know that 2 people are going to be doing large batch geocoding, instead of setting that number to 4, you would want to set it to 2.
Does that a single lookup when you do that, I know this is all batch, but if you set up a single address lookup, is that going to be impacted by that? Does it get put in Q2?
The single,
Is it a different service altogether?
it's a different service altogether. Yeah.
Right. Do you guys got recommendations on size to push up in the portal? You show 30,000. You have a recommended, like capacity-wise, like you're in a web browser. But
Sure. So the question was about recommended size of tables.
I guess max. I guess I want to know how big can I go?
Sure. So tests that I've done are, the largest I've worked with is 30 million, and it works fine. So but it's going to take a while, right?
Right, 30 million, right?
Exactly. So we do see that linear speed up, but once you're past like 30 million, something like that, I would probably recommend going over to like buying a geoanalytics server and going on the big data environment with Spark and all those clusters and stuff like that. So.
Kind of along those lines, that maybe you already answered it. But what if I'm the guy next to the guy doing the batch geocoding? There are other services that are supported on that server. Geocode is taking a bunch of them.
Sure.
If I had something going or I wanted to do something, I'm obviously impacted. And it's really an administration thing of like, well, let's put those there and these here, and you have to know that.
Exactly. So the question was, what if I'm a user that's doing routing, and the user over here is doing geocoding and submitting 30 million records? We really leave that up to the administrator. So it's up to the administrator to stop services that they're not using and allocate resources and scale up their geocoding services based on where the requests are coming in. And we trust that ArcGIS administrators will do that responsibly. But obviously, the system will choke if all of your resources are being used to geocode and you want to do some network problem.
John.
Is there a point where, if you're on a smaller end, where you go from single geocoding to batch geocoding? Is it worth it for 10?
No.
Where do you start looking at batch geocoding?
I'd say the question is, when do you start looking at batch geocoding as opposed to like single address record geocoding with find address candidates? How's your data arriving to you from the system of record? If it's a table, then it's more suited for batch work. So all these inputs we showed you essentially are batch files into our system, CSV files or real database tables. Yep. Yeah, so if it was streaming data, you can handle that either through something you develop and hits the endpoints, or there is a geo event server connector for geocoding. You could do the genuine streaming at high performance.
So one thing is how your data arrives to you, absolutely.
Yeah.
But another thing is if you've only got 100 records, you can just turn that into JSON and submit it to the Geocode Addresses API, right? And you'll get that back. So the Geocode Addresses API is great for small amounts of geocoding, up to 1,000 at a time. And I would say even if you have 10,000, you just chunk it up into 10 chunks of 1,000 and send them off, right? So this batch geocode API approach is probably for larger than that.
Well, thank you, everybody.
And we'll stick around for a little longer if you guys have any questions.
Pack up. Excellent.
Thanks.
Thank you.